I'm Jacob from the Secret Botanical Library, and today we're playing with acids, bases, and cabbages. Let's go! Some substances are classified as either an acid or a base, which can generally be understood to be opposites on the pH scale, which generally land on a scale between 0 to 14, with acids being anything below 7 and bases being anything higher than 7. With anything landing exactly at 7 being known as, well, neutral. However, the pH scale does not have fixed limits, so it is possible to have a pH above 14 and below 0. For example, concentrated hydrochloric acid can have a pH of around -1, while sodium hydroxide solution can have a pH as high as 15. There is in fact an entire family of these substances known as superacids and superbases, which I don't recommend getting into unless you are, in fact, a professional chemist. But how do we detect these pH levels? Well, it's something known as a chemical indicator, which is a substance that changes color based on the presence or absence of certain chemicals. In the case of acids and bases, the indicators are largely reacting to whether a liquid donates a proton or accepts an electron pair. An acid increases the concentration of hydrogen ions, meaning it donates the positive energy of the proton to create a bond, while a base releases hydroxide ions that accept protons or donate a pair of electrons in order to form a similar bond. Which brings us to our cabbage. It turns out red cabbage contains a type of molecule known as an anthocyanin. More specifically, one known as flavin. Flavin is a water-soluble pigment inside the cabbage that actually functions as a basic chemical indicator that turns red when it mixes with something acidic and green when it mixes with something basic. Today, we are going to test that reaction. But first, we need to create our own flavin/cabbage-based indicator strips. First, we're going to take our small red cabbage and cut it in half. After that, there are a variety of ways to get our cabbage solution. Today, we're going to be using the one that involves throwing our half cabbage into a blender with about 3 cups of water, and then blending until it is a fine, pulpy mess. After that, we're going to press our cabbage pulp through a fine mesh colander, before throwing away our leftover pulp and lining the inside of the same colander with a coffee filter. From there, we're going to run our cabbage solution through the coffee filter in batches, so that we can catch any super small cabbage particles we don't necessarily want in the next step of our experiment. Now that we have completed our flavin indicator solution, it's time to create our indicator strips. To start, we're going to submerge a couple of coffee filters in our solution before setting them on a non-stainable surface in order to dry. This could take as much as 2 to 3 hours. It's not necessarily the most exciting thing to watch, but these things take time. If you don't want to take this step, you can jump straight to looking at reactions by pouring a little bit of the indicator solution into a bunch of cups and add the liquids you want to test that way. Once our coffee filters are dried, we're going to cut them into strips about 1 inch wide and a few inches long, after which we're ready to get started with our experiment properly. Now we're going to be testing the pH levels of 8 different substances, ranging from lime juice to cottage cheese. And once we have tested them using our flavin indicator strips, we will test them on a lab quality indicator strip to verify general accuracy. Number 1 is going to be our lime juice, which naturally turns red very, very quickly, with the lab quality strip giving it a pH of about 3. Next, we're going to test the vinegar. Once again, it very easily tests positive as an acid, but officially lands only at around a pH of 5. Number 3 is our tomato, which is acidic to an almost identical degree to our vinegar. Our watermelon, which has only a slight acidity, registers as a 6 on the pH scale. For our 5th substance, we have our egg white, which is surprisingly more base than I was expecting, turning a very clear blue and measuring a pH at around 10. Now we have our 48-to-1 mixture of water and baking soda, which is once again a base and seems to have a pH of 9. And now we have our most extreme substance, which is bleach, which is so basic it turns our flavin indicator into a mixture of green and yellow, and our lab indicator shows a solid black, giving it a pH of around 13. Finally, we have our cottage cheese, which does nothing to our flavin indicator strip. Absolutely nothing. And testing it on our lab indicator gets us the same result, which means that the cottage cheese is neutral, hitting a pH of around 7 on the dot. So there you have it. While less precise than the fancy lab indicator strips, our flavin indicator strips work extremely well distinguishing acids from bases, which honestly might be the coolest thing you could possibly do with a head of cabbage. Thanks for watching.